The thing we have to first talk about before we get into building signals is what's called a signal delay. So here, the delay is tau, and I claim this signal is delayed in time by tau. So let's see how that works. An example I like to use is a unit step, because this point of discontinuity gives us a handle to latch on to where the origin is in the signal. So I'm going to pretend that my signal S is a unit step. So here it is, just U of t, just like we've seen earlier in this video. If I delay it, I claim it looks like this. So let's see if we can figure this out. The discontinuity occurs where the argument of u is 0. So argument u is still a function. It's now 0 when t equals tau. That's where the discontinuity is. So this means that this formula right now corresponds to a step that's been delayed, shifted over in time to tau. So u of t plus tau is called a signal advance. That means this discontinuity now occurs at minus tau, wherever this argument is 0. So we usually think of tau as being a positive number, so that the sign in the argument here tells if it's a signal delay or an advance. But signal delay is going to be a very important thing in building signals, as you're about to see. So let's have a little game. Let's see if you can tell me what this signal is. So we have here a unit step and a delayed unit step. It's delayed by delta, and I subtracted the two signals. What does it look like? Okay, well, let's try to plot it. We'll plot the pieces. So the unit step, of course, looks like that. The delayed unit step is just as I've shown it already. It looks like that, occurring at delta. But we have a minus sign over here. So what does that do? Well, that inverts it, flips it over. So now it looks like that. So what's the sum of the red curve and the green curve? It's 0 out here. All we get is the red guy up here, and then when they subtract, the red and the green cancel each other, and we get that. Ta-da! What we have is the unit pulse. So actually, you can think of the pulse as being a sum of the unit step and a delayed unit steps. By sum is the same as the difference here. But it's the difference between a unit step and a delayed unit step. I've now decomposed the signal into what I claim are simpler pieces. I actually look at this pulse and I see those two components when I look at it. Well, let's try an example here to see how this works for a little bit more complicated case. So this thinking about signals as a sum or difference of simpler signals is called signal superposition. This word superposition is going to occur again and again here. So superposition means just to add them up. Okay? Here's our example. How would you build this? How would you deconstruct it? How would you think, what are the pieces that you see in this signal? Okay, well, what I see is I see that big discontinuity. Right away, the first thing that jumps out is that it's discontinuous. That tells me there's got to be a unit step in here somewhere. If we put in a unit step, a negative unit step because the step is going down, at the origin, of course, that's not the right place. We need to shift it over to 1. Well, as we've seen already, that's a delay. So we just move it over, and now we get a discontinuity at the right place. All right, that's good. But now we want to talk about this earlier part of the waveform. It looks like it goes up linearly with a slope of 1. How do we describe that? Well, we can describe that by what's called the ramp function. That's why I called it R of t. And I want to point out it's the integral of the unit step. So a ramp function is 0 for t less than 0, and then it goes up with a slope of 1 forever. And that's the same as this integral. Well, okay, so now what do we got? If we add together the green curve and the red curve, let's see, we got this in this range. Always going to be 0 back there. There's no, the red curve is 0, so you get the ramp. And then you get a discontinuity because of the unit step, so it jumps down. The ramp is continuous, the unit step is discontinuous. That causes the discontinuity when you add them up. But it keeps on going forever because of the ramp. Well, that's not quite what we want. We want something that cancels this ramp part in this area, only in that area. What would you do? Think about that for a second. What signal could you add out there or subtract to make that part disappear? I think you know what the answer is. The answer is a delayed ramp. So we now have our blue signal is that delayed ramp. And when you add them all together, you get the black curve. And so our final expression for S of t is that it's a sum, a superposition of elementary signals. It has a ramp delayed, and it also has a unit step. This is what I mean by signal decomposition. Signal superposition is building signals. Decomposition is thinking about the pieces. I would also point out that this ramp is built from a unit step. It's the integral of it. So basically, this signal S, although it looks a little screwy, turns out is actually built from the pieces that build it are integrals of the unit step and the unit step itself. So the unit step is the key thing that's in this signal, even though this early part of the signal doesn't look anything like a unit step. It turns out it lurks underneath inside an integral. That's kind of cool. We're going to use this over and over and over again as we go through this course. Okay, so let's review. The important signals are sinusoids, and even more importantly is the complex exponential, turns out. The real and imaginary parts of the complex exponential correspond to the sinusoid. We've talked about the unit step. Discontinuous signals are going to occur over and over again, both theoretically and in practice. Pulses are used to communicate bits, and as we've seen, a pulse can be considered as a superposition of unit step functions. So this construction in deconstructing signals is a sum of simpler signals. Oh, is this important? This is going to make your life easy in doing calculations. And I can't stress, it also helps you understand what is going on. We'll see this in the succeeding videos.